So example 5, Lynn Pike, a pharmacist, needs 70 liters of a 50% alcohol solution. She has available a 30% alcohol solution and an 80% alcohol solution. How many liters of each solution should she mix to obtain 70 liters of a 50% alcohol solution? Now, there's lots of percents and numbers in there, but in just a general idea, this doesn't have anything to do with the problem. When you say that something has 10% acid, it means I have a container that's made up of two things, and 10% of it, just a little bit of it, is acid. If I have 90% acid, then I might have the same size container and I have a lot more acid in it and just a little bit of the other stuff. So if I want to pour them together, I'm going to get something in between 10% and 90%. So it's going to kind of level out in the middle, just depending. If I pour a lot of this one in, so a lot of the 10%, then it might end up being somewhere in here if I poured it in right there. But if I poured in a lot of the 90%, then it might end up being heavier with the acid right there and then less of the little stuff. But that's kind of what you're doing. You're going to be pouring two things together with different strengths and getting something in the middle. All right, so let's do this problem rather than just random one there. So I'm going to draw my beakers. I like to use beakers for these problems. And I'm going to pour them together into something maybe bigger right there. All right, so it says that she needs 70 liters. So I want to end up with 70 over here of a 50% alcohol solution. So I'm just going to write down here that this is going to be 50%. And she wants to have 70 total liters inside that bottle. All right, so right now she has available a 30% alcohol. So again, I'll put 30%. So that's the label on this jar. And she also has a 80%. So she's got an 80% in her cabinet. And she wants to mix them together to end up with a 50%. All right, so the question is, how much of each should she do? And we don't know. So we might call the 30%, we'll say that she's going to pour X of that. And we'll put Y here of the 80%. And we want to end up with this. So one last thing that we need to talk about is how much acid is in here. So again, if I have something small, I'll do it here. If I have something small and I have 50% acid, there's not much. Whereas here it looks like I might have 50% and I have a whole lot more. So we need to talk about how much acid is in each of our jars. We know X represents the whole thing. So 30% of X is going to tell us how much of acid is there. And then plus 80% of Y. And then over here, we're going to have 50% of 70. So I'm going to write then, I have 0.3X plus 0.8Y is equal to 50% or half of 70, which is 35. So that's going to be one of our equations. The other equation is going to be on the total amount in the jar, which is going to be right, I'll put this in a different color. It's going to be this right here. It's going to be that X plus Y is 70. So X plus Y is 70. So here's my two equations, and I'm going to use my calculator to do that and come up with my answer. And I'll put the answer up in just a second. Well, actually, you can see it in just now. All right, so I'm back here. Here's RREF, and here's my matrix that I just took from that. I did RREF, I reduced the rows and came up with this answer. So 42 goes with the X, which is 30%. So I need 42 liters of a 30% solution. And then I need 28 liters of a 80% solution, and that's our answer. So again, give a try at doing this one on the next page and see if you understand how to do that. And we'll see you next class.